In this lesson, we're going to be taking a look at what fractions are and how they work. Now, during the lesson, we're going to be using a number line involving fractions, and so we need to make sure we know what a regular number line is, and that's what it looks like. It just counts up relatively evenly spaced as best you can draw it, and so that is a number line. We'll look at it with fractions in a moment. So the key thing to understand about a fraction is that it has two numbers. It has a numerator and a denominator, and they both mean something very specific. The denominator is how many pieces would make up a whole. Denominations means a group of things making up a whole. So denominator, how many makes up a whole. And the numerator is how many pieces we actually have. So 3/5 would be drawn like this. I'd have to draw 5 boxes because that's how many pieces make up a whole, all the same amount as well. The boxes need to be the same size, and then I would have to shade in 3 of them. It doesn't matter which 3 I shade in, as long as I've got 3 out of the 5 shaded in, then that's my fraction there. Now when it comes to placing this particular fraction on a number line, here's my regular number line, just goes straight from 0 to 1 to 2. Now because this one has a denominator of 5, I'm going to have to break each of these sections up into 5 groups. And so I've done that there. Now when you're doing that, just remember it actually only has 4 dashes there, because that makes 1, 2, 3, 4, 5 groups. So we want 5 groups, not 5 dashes there, so just be careful of that one. Once I've done that, I can now place this fraction on the number line, and it's basically saying that out of the 5 groups you go across 3 of them. So 1, 2, 3, that's where this fraction would be sitting. Another important thing is knowing when it's a proper fraction, and that's when the numerator is smaller than the denominator. And so 3/5, the same fraction as up here, this is a proper fraction because the numerator, the top number, is smaller than the denominator, and that means that it's less than 1 basically. All proper fractions have less than 1 whole shaded in, and so that's it there. By contrast, an improper fraction has a numerator that is larger than the denominator. And so if I was doing 8 over 5, this is what that fraction would look like. See, each of the boxes, it still only takes 5 of them to make up a whole, but I've got 8 of them, which means I've got more than 1 whole. So the first 5, they fill in the whole lot, so that's 1 whole there, and then the next 3 here. So that makes that an improper fraction. That's what it's called. It doesn't mean it's wrong or anything, it's just the terminology we use, improper. Now finally, you can actually have fractions that are exactly the same as a whole number. If the denominator goes exactly into the numerator, it's going to actually be a whole number. So if we look at 10 over 5 here, and I draw out my boxes of that, well, the first 5 go towards making up that whole, and the next 5 go towards making up that whole, and there's no boxes left over. And so that's actually just exactly the same as the number 2. It's just a whole number. So let's take a look at an example. I'm going to represent 1/3 and 5/3 on the same number line. So let's start by drawing out our number line without the fraction parts yet, just a normal number line. Leave plenty of space between 0 and 1, because you know you're going to have to break it up into sections, and make sure whatever space you got between 0 and 1, you got the same between 1 and 2. You might also want to go up to 3, up to 4. You'll find out soon enough if your number line was too long or too short. If it's too short, it's all right, you just draw it longer. If it's too long, oh well, better luck next time. So see, the denominators are 3's here. That means that we need to separate each one into 3 sections, and I do that by doing 2 dashes in each one. So that's 1, 2, 3 sections. 1, 2, 3 sections. So 1/3, that's easy enough. I just count across 1 section from 0. Count across 1, that's where it is. For 5/3, I'm going to have to count across 1, 2, 3, 4, 5 sections, and so it would be right there. In the next example, we need to write the next 3 fractions after these ones. And so notice these are all 7s on the bottom. That's because there's always going to be 7 that make up a whole. So that number's not going to change. You often find that in fractions at times when the denominator doesn't change, because that's saying how many pieces make up a whole. If you're not changing how many pieces make up a whole, then of course the denominator doesn't change. But the top number is how many pieces we actually have. And what's clear here is I start with 2, and then I go up to 5, so I've added 3, and then I go up to 8, so I added another 3. So I can work out the next one easily enough. The first thing I have to do is write down just the original 3 numbers and then the next numbers. And so the next one is going to be 11 over 7 because I add 3, and then 14 over 7, and then 17 over 7. Remember, the denominator is not changing at all here. I'm just adding 3 each time to the numerator because that is the pattern I've got here. Right, and the next example we're just asking is 8 over 4, is it a proper fraction, an improper fraction, or a whole number? And so we do our little quick test here. Is the numerator smaller than the denominator? No, it's not. Is the numerator larger than the denominator? Yes, it is. So it might be an improper fraction, but we just have to check for the whole number. Does the denominator, there's 4, go directly into 8 without remainder? And it does, doesn't it? And so that means it's actually a whole number. And you don't need to write the next bit down, that green section. That's just a quick explanation of why, because 4 goes exactly into 8. But you could just write down whole number, improper fraction, or proper fraction. That'd be fine. So let's try some practice questions with it. Remember to pause the video. And there's our solutions to those ones. With the first one here, I noted, first of all, I drew out my normal number line, just 1, 2, 3 here. And I was really thinking ahead a little bit. I knew I'd need to go up to 3. Remember, if I only drew it up 1 and 2, when I came to put this 9 over 4 on, I'd suddenly realize, whoops, I should have gone up to 3. So it doesn't matter if you're a little bit short to start with. But I knew I'd have to go up to 3, so that's what I did to start with. And then I separated each section into 4. And that's because of this 4 down the bottom here. And so I used 3 dashes to separate it into 4 sections. Remember, you'll always use 1 less dashes than the number of sections. And then I had to represent 3 over 4, so I just counted across 1, 2, 3. That's where the first one is. And then for 9 over 4, once again I counted across 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why that's 9 over 4. In the next one, I had to write the next 3 fractions. The denominator's not changing, so I knew that they'd all be 5. So that's fine. I just looked at the numerator. 1, up to 3, up to 5. What's the pattern? It's going up by 2. So I just continued that pattern for the next 3 fractions. And then in the bottom one, is 3 over 7 a proper fraction? Well, it is, isn't it? It's a proper fraction because the numerator is smaller than the denominator. And so it can't be a whole number because the denominator certainly doesn't go into 3. 7 doesn't go into 3 without remainder. So I just wrote down that it is a proper fraction. Here's some more practice questions. If you need to have another go, remember to pause the video. And there's the solutions to those questions. And that's the end of this lesson.